Okay, so welcome to this walkthrough short tutorial just to introduce RobotStudio and some of the capabilities. This is a pretty simple one with a robot just drawing some characters H and V, and it is not done in the best way, but just to illustrate how to go from the modeling of the robot station to rapid and controller and vice versa, and some rapid editing, some simulation setup to run different simulation scenarios and so forth. So here we are. Okay, we will start with an IRV 140 6 kg robot, and we create a new solution with station and robot controller. We create, and some information will pop up when the system starts up like this, and will ask us which robot to use. There are two versions. We click the first one and OK, and it will pop up like that. And yeah, and then I have a few items from the library to import. First one is a robot table with a stand for the robot. It's located like this one. Everything comes if it is doesn't model, if it isn't modeled in another way, just in the base of the world object frame, world coordinates. And now we have to lift the robot and put it on the stand, which is located around here, 670 millimeters up. So if I click on the controller tab here, and we have task frames here, so I can raise the frame of the robot to 670 millimeters and apply. I also want to move the base frame, which is located in the middle of the robot, like that. Close this one, and now we have location like this. Okay, so, and we have a few more items to import from the library. We have a paper to draw on. It has been saved in a way so it pops up in the right position already. It has a small height like this, but otherwise it's just a rectangular object as a paper on A3 format. Now you see when I zoom in and zoom out, it will be difficult to make a rotation. Sometimes that happens. I can right click on, for example, this one and view center, and now everything is quite okay, and to move around like this. Okay, now we also import from my lab the pen, which is the tool to work with. Now that comes up in the origin of the world, so to say, and to get that to the robot, we just take the pen here and drag it on the robot, and we want to update the position of the pen like that. So we have a 2 center point here with the pen as the tool. We still don't have work object other than the base of the robot, basically. And if we want to check how things works, we can right click on the robot, and we can do a mechanism joint, for example. Fifth axis, can set that to 45 degrees, for example. If we want to make some rotations, we have jog reorient, like that one of the tool. That. So this to be working pretty well. Okay. close that one. Now this can be a home position, so we just teach that as a target. Yes, that one. And if we look at the paths and targets here, go down along, and then we have the target 10. Okay, so that is the home position. Now we should be working on the paper with drawing something. So what we have to do is actually to define the work object, which is on the paper. And we start with the left lower corner and put it like here. And we have on other, we can create work object. We can name it paper, for example, whatever. And we have a user frame values. We have to have snap mode, snap ends, for example. Now, if we change things here, we better point at this one here, which should be changed. We snap on this one here. We get some data from that point, 450, 125, 120 in X, Y, Z, except that one. We have some values for the rotation. We want the Z-axis to point downwards, which will be the same as the tool center pointer pen on the robot when it is writing. So we have to reorient around the X-axis 180 degrees, except that one. Now we have object frames that are defined based on the user frame here. So we move that 50 millimeter in X, Y. Like that one. 50 and 50. That one. Now everything should be pretty much okay. It's just one thing to think about, that now we will only just scratch the surface with a pen. The pen is a spring-loaded pen, and it is better that we try to do it in a way that we go down a few millimeters. So if we change the user frame, for example, and put it here like 118 millimeter instead, then that will be 2 millimeter below the surface as it's drawing. And we click create, and it will be like this one. So this is the user frame, this is the object frame. And now when we start with 0, 0, we will start 50 millimeter inside the paper. Okay, so the next is to define some targets. Now we start with an H. We draw it like from here to here, 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 from here to here. And this point here is 100 millimeter in X. We have X like that and Y like that. And 0, 50 in the middle, and we start with the target. So the next is to define the targets for the drawing of the characters H and later on a V. So we can select to change the velocity down here to different values. Like in this case, I have 100 millimeters per second. The zone can be whatever here. It is originally 100 as default. I put it to Z1, and the pen as a tool, and the paper is work object. So I create a target. The reference should be the work object, and the target name would be H_10 for the character H. And then position, the first position is 100 in X, and 0, 0, we add, so it is positioned here. The next one will be down here, which is 0, and we add that one. And the next is when we draw that, and that is 50, and then we have a 50 on the Y, and then we have 100 here, and 50, and 0, and then we have a 0 there, and 50, 0. So that can make an H. And we just create those. We get the values here. And what we do now is just to check that we can walk through, but first we have to actually create the path. And we create, right click, create path, right click, left click on that one, and we call it path underscore H, like that one. Now we start with the home position, target 10, drag it down to that one, open up. So it is included in the path H. And then we take all of these, that shouldn't be included. Like that. Sorry, I did a mistake, but that can be changed by in this way. Rename and take all of these, drag them down. They will follow the first target in this. Now we can see that the first one seems to be quite okay. The robot can reach it. It is actually already in that position. But the rest are undefined by the system. So we need to define the configuration of the robot. If you right click on that one, we can include configurations, auto configuration. And we'll try to find a solution for the robot. In some cases it put a question, how should I do? In other cases it seems to be pretty much okay, so just run through the whole sequence. Yeah, now we are ready to synchronize this to Rapid, and that will create the code in Rapid for this station. And that is done here. And go to the Rapid, and then we go down to the Rapid system here. We have module 1, and that is path H. So if we double click that, we see all the targets here with the data. We have the path H with the move L instructions, and from that we can go to the simulation tab and make a simulation setup. Click on the Rob1, and we take the path H as an entry point, and U1, then we can run that simulation. Well, yeah, that works. But now we see that the pen is always down in the paper. Maybe we don't like to do that. We would like it to go down and raise, and so forth. So if we go back to the Rapid code, we can actually do some editing here. And that means that we can, for example, for the first one, say that we would like to have an approach Copy that one and paste. So for the first one, we do an offset. And that's an instruction to go make an offset in relation to target. And the offset is minus 15 millimeter in the Z direction, meaning it is weighting above the paper. And then we move down and right to target 20. There we do the same, we raise it. So like that one, and we make an offset. Like that. And then we move to the middle of the H. And above the paper. $50 millimeters above. And then we move to the where we are the middle, go down again and draw the 40. And then we raise it like here. And then we do the same. We move to the starting position of drawing from upper right corner of the H and down, moving that, meaning that we move up. Like that. And then down, draw here, down to that one. And then we are pretty much ready. We do like this, that we take this also in a nice way, just to now all this editing here could of course be done in a procedure in a nicer way, but for this first tutorial we just make it like this one. So, and a few more things. We have the target here. We could go in a bit faster, 1000 millimeters per second. We don't care about the set value 100. And for this one, we also move fast down. We may have a set value of 10 instead, because we're moving down additional 50 millimeters, so 10 is quite fine. And I think this is about it. This could also be 10 at the end, like that one. And what happens now? Well, we have to apply the changes. Apply changes here, and it has no errors. That's fine. If there was an error, it will be highlighted, and we have to change that. For example, do like this, and just make an apply changes. And it says syntax error. Well, yeah, that's a bit red here. So we put that again and apply changes, and no errors. Fine. So now we have to synchronize back to the station. Pick everything. Okay. Station completed. And go to the simulation. And now we run the same path. So yeah, seems to be running as intended. Now we're ready to add another procedure, making the V character. So we change the work object here. Everything else is pretty much okay, except that we have V underscore 10 as naming. And we start now with position X is 100, upper and left of the V, and this could be also be 100 and 0. So we add that one up here, then we go down, meaning 0 and 125, add here, and then we go up again, meaning 100 and 150. Yeah. So we break those, we get them here on the work object paper, and we can now create a path underscore V, and we just drag those down to that one, and they are here, and we end by going up to the whole position. Now we are standing on the path V. We need to do this configuration, auto configuration, and we take the first one. As you see here, there are a number of different alternatives. 4 in this case, it could be more or less. So they looks a bit different, but we take the first one, apply, and now everything is defined. And what we do now is to make a synchronization to repeat and check everything. Okay, and we go to the repeat here and do some minor editing as before. So we started here by lifting the pen above the paper from the last position of the H character. Now we move to the first one, so we need to be above the paper. Meaning that we need to be offset here. Like that one. We can move a little bit faster, maybe 200, 300, whatever, doesn't matter really, but we keep the set value. And then we move down to that one, first of the V, second, third, and then we move up from that one. So we actually copy that one and paste. So we have one offset like that one. And maybe raise the set value a little bit like that. And now we do a apply all changes, no errors, that's fine. We make synchronize to the station, check everything, okay, and then we can move to the simulation tab here. We have to actually, we can check now the V and that one. That seems to be working fine. Now we have a main routine, main procedure. The main procedure is the procedure that gets the ball rolling, so to say, all the time. And to get a full program running, we need to include the paths in the main. We drag them into the main like that one, and that one into the main, and it will be like this. Now we have to synchronize to the rapid again, or to the controller. And to get everything in place, as we have changed things, and we can now do a full simulation. And here we can check that the main is the entry point, and check how it looks like when you run the full simulation. Just a final view. That one. Okay, that's all. Bye.